welcome back to this class, and we have covered turning flight, right? Now in this class we will cover the pull up and pull down. So we will discuss what is mean by pull up, how you define pull up, pull down, and how can you perform this maneuver, what is the math behind it. Okay, each and everything we will discuss. Okay, so generally pull up means, for example, like a consider this is aircraft is a steady state level flying, and if you are changing the flight path angle with time, okay, changing the flight path angle with time, this is nothing but the pull up. Okay, circular path, right? You are taking a circular path, and in this condition if you do the maneuver, it's a pull down. Pull up and pull down. So consider this point as a point A and this point as a point B. Okay, now your aircraft is flying like this. Thrust opposite to this, there is a drag, and this is lift, and weight is acting downward. Okay. So this is the case, and from this point, at A point, your aircraft was in steady state level flight, and from the A point itself you start pulling up the aircraft. And how will you do the pull up? You will put the maximum uh, uh, throttle to get the excess power in order to get the lift greater than weight, and then simultaneously you put the elevator up to rotate the aircraft. So by this you can achieve the pull up maneuver. So in this condition, every time your flight path angle is changing with the time. So what is the difference between climb and pull up? In pull up also you put the maximum throttle or some throttle setting which is greater than the power required in the cruise, and you will get the excess power and you will get the climb. But here what you are doing, you are putting the maximum throttle and you are rotating the uh, elevator also. Okay, each and instant. Okay, so let's say for example, like you put the throttle, you deflect the elevator, you was there some gamma, again you deflect the elevator and put the some other throttle setting, your gamma is changing. Okay, so here your gamma is changing from 0 to some degree, right? So continuously the flight path angle you are changing, and this is how you are performing the pull up. So in this case, if you at a point A, you can write L minus W is a net force, and what is the net force? It's M into F equal to ma, right? So we will have a external force equal to rate of change of momentum. Here M v square by r. So L minus d equal to m v square by r is nothing but the equation of motion. So now you divided by W, what you will get? L by W minus 1, and this you can write W by G, and W will get cancelled and you will get V square by GR, and this is N minus 1 V square GR. So you can write R equal to V square G N minus 1. And if you consider this point B, so where your aircraft is inverted, your aircraft is like this. Okay, so now your lift is acting downward and weight also acting downward. Okay, so at point B, point B is in what case? pull down, right? L plus W mv square by r. So you can write n plus 1, similarly what we have done for the pull up case, and you can write r equal to v square g n plus 1. Okay. So what if fly in any generic case here, for example, your weight will act always downward direction. For example, this is thrust and this is weight will act at this is center, and if you join this line, and lift will be always towards the center only. You draw the vertical line here, and this is theta. Okay, so you can write the generic case L minus W cos theta equal to mu square by r, generic case. Generic case. You can see here, if your thrust is this and drag is opposite to this, and this is W, and this radially direction is lift, and this is theta. Okay, so if this is theta, so what will be this angle? This will also be theta, right? Only you just extend this line, right? So for example, like a this angle and this angle will be same, right, from the geometry, right? This angle will be same, right, from the geometry. So this is W cos theta, right? So L minus W cos theta will be mu square by r. Correct, right? Generic case, right? At point A, your theta is, what is theta? See, at point A, your theta will be what? ये दोनों लाइन कोई एंगल नहीं बनाएंगी, राइट? 0 डिग्री रहेगा, राइट? भाई धीरे धीरे करके लेके आओ, यहाँ पे लेके आओ धीरे धीरे करके. लिफ्ट भी नीचे उसी लाइन में रहेगी, वेट भी उसी लाइन में रहेगा, ठीक है? तो आपका 0 रहेगा, राइट? So if you put 0, what will you get? At theta equal to 0 case, L minus W mv square by r, right? तो थीटा इक्वल 0 पर पुल अप केस हुआ कि नहीं? पुल अप केस, राइट? At point B, what will be the theta? 180 degree. So theta is 180 degree. Cos 180 degree is how much? Minus 1. So L plus W will be m square by r. This is what case? Pull down case. So that is why I explained with a generic case. It is not every time you will be here at a point A, and here you see, apart from this 2 point, we have to fly at this point, this point, this point, every point, right? And do not confuse with the theta with the pitch angle. Here the theta is a what angle is lift is making with this vertical line. That is nothing but that is angle theta. Okay. So this decides at a point what angle you are having and what point at B what you are having. Okay. Put theta equal to 90 degree. Can theta be 90 possible? तो 0 हो रहा है 180 हो रहा है तो बीच में 90 तो आएगा. So what is the scenario of this case? So 90 की डायरेक्शन कैसे होगी? 90 की डायरेक्शन ये होगी, राइट? So exactly lift will be mv square by r. और थ्रस्ट क्या होगा? इक्वल टू वेट. तो एक तरीके का रॉकेट बना दिया आपने अगर यहाँ पे देखा जाए, थ्रस्ट इक्वल टू वो वेट वाला सी से अगर देखा जाए तो. ओके, नाउ द थ्रस्ट विल बी इक्वल टू ड्रैग प्लस वेट. ओके, so no W component is contributing in mv square by r case. Okay, please tell me, if I am flying like this, what is my flight path angle? I am vertically flying up, right? 90 degree only, plus 90 degree only, right? Okay, and if I am flying like this, it is minus 90. Are you sure minus 90? How the flight path angle is defined? Flight path angle is velocity and horizontal. This is right. Okay, so let's say for example you are flying like this, right? So horizontal is this, velocity vector is this, so plus 90 making sense, right? And now plus 9 minus 90, right? So even if you are if you are saying something now, you have to be very confident that okay, this is a plus 90 case, this is a minus 90 case. What will be the this case? This case just at point B. Can aircraft fly inverted? Aircraft can fly inverted, right? So if the flight is this steady state level flight, what is the flight path angle? 0, right? So at point you can say it is 0 only. So are you aware of CL naught? You use the camber airfoil where you can fly the negative angle of attack also. Okay. So in this case also you can fly the negative angle of attack, and here also you can fly the. So you can fly the inverted, absolutely no problem. So this is about the maneuvering flight, but see, you are this making that turn. We have seen the turn case, right? And now this is pull up. So this is nothing but the making a circle in a horizontal this way, and for a pull up pull down because this is making the circle like. In both the cases, only loop is different. One is horizontal and one is vertical loop. Okay. So consider a scenario like very high speed you are flying and you are making this turn, or very high load factor you are banking and making very high bank turn, and similarly for the pull up also very high load factor. Do you think both the things will be the same? Let's see. So in turn case, what we have derived this case, right? This case, right? And for pull up case, this we have derived. I will say pull up pu, and this is v square g n plus 1, this is pull down. Okay, and this is turning flight. You put n, you put the condition here. Condition is n is very much greater than 1. So you can take n plus n square minus 1 as a under root n square, and then you can consider as a n, and n plus 1 you can consider as a n, and n minus 1 also n approximately. So in all three cases you put under root n square minus 1 as a n, n plus 1 as a n, n minus 1 as a n. For the lever turn, the r will become v square into gn, and r for pull up also will become g into v square divided by gn, and r for the pull down will also become same, right? So this is lever turn, I called it, and this is pull up, and this is pull down. So in all case, you can see the radius of turn expression is same. So that means at a high load factor, if you are taking turn, or either you are pulling up or pulling down, your radius remains the same. Okay. Now at each instant you can find out the turn rate also. Turn rate is given by v by r, and what is your r? R is in the, consider this condition, what is the r? V square by gn in all the cases, right? V square by gn. Okay, so now you can write ng by v. So omega is ng by v. So how will you achieve the max turn rate, turn for pull up? You may substitute, obviously you have to fly a very high load factor. For example, let's say if this is an aircraft, and if you are flying with a maximum with high load factor, okay, you will get more turn rate. So if you want to perform very aggressive maneuver, what you will do? You will increase your angle of attack to this CL max, and then utilize the full load factor to pull up full throttle. Okay, and then you will get the omega max. And what will be this r expression? R expression is v square by gn, right? So v square by gn was the r. Okay, and you may write as a 2 nw divided by rho scl into divided by gn. 2 nw rho scl, correct, right? From lift equal to nw. And now you can further rewrite as a 2w n rho g s, or you can take w by s and n here. Okay, rho g and then cl. If you are flying at a max cl, your turn radius will be minimum. So now in this case your r minimum will be what? When you put CL max, you will be having the r minimum condition. So we have seen that in this lecture what is pull up and what is pull down and what is a generic case. and we have derived the expression for the turn radius and as well as the turn rate for each the considered case. And we have find out this omega max and r minimum condition also. And we have also seen that if you fly with a very high load factor, your level turn, pull up case, pull down case, all case, in all cases your radius of turn will be equal. Okay, and your turn rate also will be equal. So thank you very much.